George H. Corliss ranks with James Watt in his contributions to the improvement and refinement of the steam engine. Born in Easton, New York on June 2, 1817, he began his working life as a store clerk and inspector for textile manufacturers. In 1844, Corliss moved to Providence to organize a new company under the name Corliss, Nightingale and Company. There, in 1848, Corliss invented an improved means for controlling the amount of steam admitted into the cylinder of a steam engine under varying load. The Corliss engine, in myriad forms, became the standard factory prime mover of the late 19th century. To commemorate the 100th anniversary of the founding of the United States, it was decided to hold an international exhibition in Philadelphia in 1876. It was a great exercise in selling, as businesses in all fields and from all parts of the country and from abroad set up booths and exhibits in order to attract orders. Corliss offered to supply a single large engine with boilers and shafting to drive all of the main mechanical exhibits planned for Machinery Hall. All kind of bureaucratic delays meant that construction did not begin until June 14, 1875, allowing only 10 months to design, build, transport, and erect about 700 tons of machinery. Corliss's 1,400 horsepower monster engine, claimed to be the largest in the world, stood at the center of Machinery Hall, where the South Avenue intersected the central transept. The hall was 1,400 feet or 420 meters long, 360 feet or 110 meters wide, and stood 70 feet or 21 meters high where the engine was located. The rain ceased on the morning of May 10, 1876, as 10,000s of people gathered in front of the main exhibition building. After music, prayers, and speeches, President Ulysses Grant declared the exhibition open. President Grant and Emperor Dom Pedro of Brazil led a procession of officials and invited guests from around the world, touring through the main building and into Machinery Hall. When they arrived at the Corliss engine, Corliss stationed the president by the left steam stop valve handwheel and the emperor by the right, where each had a silver crank. George Corliss spoke.
"It does not happen often in a man's existence to station two rulers of such nations at their posts to await his word of command. Are you both ready? Then your majesty will turn that handle."
A sound of a rush of steam. The great walking beam is seen to move.
"Now, Mr. President, yours."
The sound of steam is multiplied, and the other engine joins in the work. Within seconds, all the machines in the hall were working. These machines performed all sorts of tasks, including combing wool, spinning cotton, tearing hemp, printing newspapers, lithographing wallpaper, etc., etc. The Centennial engine was the last American beam engine of any consequence. Although at the time the style was regarded already as completely obsolete, it is clear that Corliss employed it there for its monumental visual effect, and it was acclaimed as the ultimate manifestation of American technological prowess. For better visibility, we removed the building structures and decreased the rotational speed of the engine. The Centennial engine consisted of two identical Corliss engines, with one common flywheel and one crankshaft on which were attached two cranks, shifted by 90 degrees one to the other. Also, the governor was common to both engines. The total height of the engine was 40 feet or 12.2 meter. The cylinders were two in number, each 40-inch or 1 meter diameter, and 10-foot or 3-meter stroke with piston rods of steel. The cylinders were elaborately insulated, having a steam jacket, hair felting, a half-inch airspace, topped off by a polished iron casing. The casing for the cylinders and side pipes was a series of elaborate cast iron rings finished in a lathe and cut to make two half circles. Each beam was a single casting 27 feet or 8.2 meter long, 9 feet or 2.7 meter high in the middle, and weighed 11 tons. Corliss estimated that the best scrap iron for making wrought iron was horseshoes, so about 9,600 horseshoes went to make the 24-foot or 7.3 meters long connecting rods. Steam is brought to the cylinder by the steam side pipe, and the spent steam is evacuated from the cylinder to the condenser by the exhaust side pipe. Two rotary valves at top and bottom of the cylinder control the fresh steam flow in and spent steam flow out of the cylinder. These valves are driven by the eccentric wheel on the crankshaft through levers and wrist plates. For the steam valves, its drop of instance is controlled by the governor. See Part 2 of these movie series. The governor maintains the speed of the engine at a so good as constant value by controlling the drop-of instance of the steam admission valve, a major and patented invention by George Corliss, allowing an increase of efficiency of the engine up to 30%. The flywheel was a gear, 30 foot or 9.1 meter in diameter and 24-inch or 0.6 meter wide, with 216 cut teeth and weighing 56 tons. The crankshaft was common to both engines, 19-inch or 0.5 meter diameter and 12 foot or 3.7 meter long, was of best hammered iron, and the cranks weighed 3 tons each. The quietness and smoothness of operation of the engine was widely remarked upon, said the Scientific American Supplement.
It is impossible to detect, at any time after they have been put up to speed, the slightest variation in the number of revolutions. The engines run as smoothly and noiselessly as a watch, and nothing can be heard but the slight swish of the dashpots as the steam valves are tripped.
The press was filled with comments about Corliss's monster engine. Engineering said,
"The engine as erected is in such harmonious proportions in its different parts, and compares so well in dimensions with the building that contains it, that one loses all sense of its immensity in the contemplation of its beauty and strength."
Various publications have stated that Corliss's vast Leviathan was the largest and most powerful steam engine in the world. However, other engines did approach, or even exceed, the Centennial Corliss engine in physical size or power. One such example was the very large pumping engine named the President, which was set to work in 1872 to pump groundwater out of the Friedensville mine of the Lehigh Zinc Company in the Lehigh Valley, Pennsylvania. This massive beam engine had a single cylinder 110 inches diameter by 10 feet stroke, and the engine alone weighed 657 tons. It was estimated at 1,600 horsepower and could raise 19,000 gallons per minute from a depth of 350 feet. The engineer estimated that the President was the largest fixed single-cylinder engine in the world, and it certainly had greater weight, horsepower, and cylinder volume than the Centennial engine. The Corliss Centennial engine was, however, undoubtedly more elegant and much more efficient. The Centennial Corliss engine remained in service long after the exposition closed. George Pullman, president of the Chicago-based railroad car manufacturer, purchased the engine to power one of his factories. The old engine was not scrapped until 1910, after 34 years of service. By then, the old-fashioned Corliss engine was completely obsolete. It had been supplanted by Charles Parsons' compact, much more efficient steam turbines and electrical motors, which are still used in power plants and ships to this day.